So we will go through, this is 1.8, 1.10 through 1.10 quiz review. The first part of your quiz is going to be, you're going to have 10 numbers and you have to classify them. So if you remember our number flow chart, remember this, where it's real and then irrational or rational, and it flows all the way down. The furthest one it can go into is the one you want to put it, that's where you want to classify it. So if it goes all the way down to whole number, you're going to put it in here as whole number. So -5 would be, we would go, it's real, right? It's also rational. Remember, if it's a fraction or a decimal, we stop. Is -5 a fraction or a decimal? No, so we continue. It's an integer. Is it a negative?
Yes.
Yes, so we stop. So it would go all the way into whole or integer. So we're going to put that in this circle where it includes that. So all the circle includes everything else inside of it. So, or I mean below it. So no, because it's a negative. So it will not. You stop at integer if it's negative. No, you stop at integer if it's negative. So this -5 is also a rational and integer. I do want you to put whatever the original form is, but if, like, the next one is square root of 121. Square root of 121 is what? It is 11. So we have to think about classifying that number. It is a whole number, did you say? It's real. It's rational. It's an integer. Yes. Remember, if it's an integer and it's negative, we stop, but it's not negative. So we're going to keep going. It's a whole number. If it's 0, we stop. And so it's natural. It's all the way down into natural. So no, if it's 0, we stop. Okay, so we're going to go and put square root of 121 inside of our natural circle.
Wait, so our test is going to have this.
It's going to have this on it, yes.
Can I just do arrows?
I mean, try not to, but if you absolutely have to, sure. Okay, the next one is a repeating decimal. Repeating decimal is always what? It goes on, but it repeats. Nope. So let's go back here. Real, rational. If it's a fraction or a decimal, you stop. Because it's a decimal, we stop at rational. So it's 4.2 repeating. If it's a fraction or a decimal, you stop at rational. Well, my next one is another fraction. So where does that go?
Rational.
Same thing, 5, 6. You could even, some people like to do this, go through and say all of my decimals are going to be there. So -4.3. It does not matter if it's positive or negative. If it's a decimal, it goes into rational. Just because I'm 7.4.
Can we get our notes on the test?
No. Yes, Katie.
What's in the small circle?
Natural, and that's square root of 121 because it's equal to 11. Okay, then, yes. This one, don't worry about that negative sign. Worry about the square root of 21. Is 21 a perfect square? No. So that's going to go into my irrational. So square root of, and it's negative, of 21. Negative square root. Because nothing, not a whole number multiplied by itself will get me 21. 4 times 4 is 16. So 16 is a perfect square. The next perfect square would be 25. 5 times 5. It has to be a whole number squared. And those are perfect squares. Okay, so we did this one. Again, remember to write the whatever's in these boxes or whatever's up here into here. Okay, square root of 15. Is that a perfect square? No. So it's going to go down here again. Because a number, and honestly, okay, do this. Take a calculator and do square root of 15. If it's not a whole number, if it's a decimal number, it's not a perfect square. Okay, you can check your work that way. So it's irrational. Now, this negative was on the outside. I want you to look down here. This negative is on the inside. So that means this is what? Imaginary. Negative. If it's on the outside, it's just irrational. If it's on the inside, it's imaginary. Okay, then the next one is 36 over 6. Why didn't I write that in here right away when I was writing all the fractions and decimals down? Because it simplifies to 6. So 36 over 6 simplifies to 6. That's going to go all the way into natural. So I want to write 36 over 6 inside there. That would be an example where you could probably draw a line if you really needed to. Okay, did we do them all? We sorted them, so we sorted each one into the correct category. All right, evaluate. Again, you can use a calculator. So you're going to evaluate and then fill in the blank with a greater than, less than, or equal to sign. So the first thing you want to do is 4 minus, I want to find the square root of 2. So again, square root of 2 is 1.41. I would round it to the nearest 100th place. Square root of 36. What times what equals 36? 6. Why was 1 times 1 not 2? Because 1 times 1 is 1. Okay, so remember, this is what times itself. So 1.41 times 1.41. It goes on and on and on, but we're gonna round it.
How's that?
It would not, if I multiplied this number, if I did that, it should give me 2. Because it's, but if I do 1.41 squared, it's going to give me a number that's really, really close to 2. But that's why it's irrational. If I round it, if you ever round, you're not actually getting an exact answer. But when you're working with square roots of non-perfect squares, you're going to have to round. But here, this is an exact answer. 3, I want to change this also to a decimal. And I do the top number divided by the bottom number. So this 3, and then this is 0.5, right? Now I need to figure that I'm going to do the math. 4 minus 1.41, 2.59. And then 6 minus 3.5 is 2.5. What's after this if I really wanted to put something there? 0. Now, if I look at my two numbers, which is bigger? 2.59. Any questions? Well, this one is 250. Yep, 2.5. Yep.
Wait, if
Go ahead.
if the negative up for something that's like in a box, the negative, so for this one above it, the negative on the outside is imaginary.
No, if the negative is in the inside, it's imaginary. Okay, the next one you're going to have to order. But again, you're going to have to put them all in the same form. Put them all as decimals. So find the square root of 15. So that's a negative and round again. So 8, 7. So I'm just going to take those two. The next one is a 2, so I'm not going to round it up. Square root of 17. 4.12. Why does this one negative? Because up here is negative. Okay, and then these two are already in decimal form. And now I want to go from least to greatest. So I have two negative numbers. Which one is smaller?
Negative 4.5 is small.
This one is smaller. So when they're both negative, it actually looks, the smaller number is the one that looks bigger, right? So this is going to go first. So negative 4.5. Again, when you're writing in them in order, you want to write the originals from up here. So negative 4.5 and then negative square root of 15, right? Because that's my two negatives. I like to cross them out to know that Then which one's bigger? Or smaller, sorry. I'm going least to greatest. 4.12, right? So that would be square root of 17 next, and then 4.5. So this is already worth 6 points. This is a point. This is a point to change them to decimals. And then each one in order is going to be a point. So there's 6 points right there. You have to show this work, these two at least. Okay? All right. I'll come back. I'm going to finish the video so I don't run out of time. All right, this you have to circle the irrational numbers and explain why it is or is not irrational. So first, 2/3 is a fraction, so it's rational. 5.6 times 10 to the negative fifth. If I move my decimal, it's going to be a really small decimal, but it's going to be a decimal, so that is rational. Square root of 15. Irrational. It's not a perfect square. So I'm going to circle it. So I would label this, I would say rational, because it's a fraction. Easy as that. Because fraction. Or because it is a fraction. This is a decimal, so rational. No, because it is a decimal. Doesn't that seem pretty easy? If it's a decimal, it's rational. This one's my big one. Why is this one not, or why is this irrational?
It's not rational. It's not a full square.
Okay, it's irrational because it is a square root of a not perfect square. That's why it is irrational, and you will need that.